All right, welcome back to Principles Engineering, and we're looking at trusses once again. So now where we are within our truss structure is we've solved all of our external forces. Just prior to this, what we found that our force at E in the Y direction was 500 pounds. We found also that our force at point D, reactionary force, is 1,500 pounds up. So now we know all of our forces external to the truss. So now I can look at individual points. So let's start with the simplest point, and I'll be honest with you, the easiest way to do this is to start with the point where you know the most about it. And what I can tell you is at point E, I know almost all the forces here. So it's very simple, and there's only two vectors coming into it. So let's start out at point E. Now, it doesn't really matter how you draw your truss, your free body diagram at E. So this is E, and I'm going to go ahead and say that that member is going to be in tension. Likewise, I'm going to say this member is in tension, or in compression rather. The reason I'm saying that is because I have RF, EX going the opposite way, and I'm just drawing my vectors opposite of the known forces that I have. So I'll draw my known forces here as RFEY, and that we already solved. We said that's 500 pounds. And we have RFEX, which is 0. So let's start out and look at this and go on the premise that the summation of our forces, if this point is not moving, the summation of the forces in the x direction has to equal to 0. The summation of the forces in the y direction has to equal to 0. Let's start out for F in the x direction. So by saying that the sum of the forces in the x direction equal to 0, I'll go through and I'll look and say, what do I have? Well, I've got a force right here, but it's 0. So this force pushing in is, I'm going to call this the force DE. So F, D, E. And all that I'm going to say is F, D, E plus 0 has to equal to 0. Pretty simple solution, isn't it? Therefore, F, D, E equals to 0. And I can go right back to my force diagram, and I'll go ahead and update that, and I'm going to put this in a 0 force. So coming back out here, let's go and do our forces in the y direction. Similarly, those have to equal to 0. So what do I have in the y direction reacting? I've got the force, reactionary force E in the y direction, which is 500 pounds down. So I can say that is a minus, well, let me just put it in here. So reactionary force at E in the y direction plus what other component force do I have? I've got the force from C to E, so I'll draw that and label that F, C, E. Plus FCE has to equal to 0. Those are all the forces that I have working in the y direction on my free body diagram. So we know what the reactionary force at E in the y direction is, and that is a minus 500 pounds plus the force CE has to equal to 0. And what that tells me is the force at CE has to equal to 500 pounds. And we get that by adding 500 pounds to this side of the equation and then adding 500 pounds on the other side. And what you get is that zeroes out and FCE equals to 500 pounds. That's how I arrived at that. Now this 500 pounds, it's important to understand, what does that plus sign mean? That means that it is positive, therefore it is an upward force. Now I've drawn it as an upward force When I'm pulling from the point, what that means is the force is in tension. Tension. So I'm going to go ahead and write that into my diagram here, and I'm going to label that. And this, well, we'll just put it into the diagram in the right place here. So this ends up being 500 pounds in tension. Tension. Okay, that's the force at E. Pretty straightforward and pretty simple. Once again, at point E, we've said the sum of the forces in the X and the Y direction are all 0. Thanks for watching. Next up, we'll move over to point, let's move over to point C.